So I decided to take another look at using GitHub's Copilot, and while the debate about the efficacy of vibe coding and specification-driven development rages on, there seems to be a consensus that AI-assisted coding is here to stay, and that Copilot's kind of become the standard for most enterprise developers. Now, as early as 2023, I've been pretty bullish on the use of LLMs to help with coding. I've even published a few videos showing how I've used it with prototypes, test-driven development, writing requirements, and it works pretty good. But still, after trying out early versions of Copilot, I just wasn't feeling it. I didn't like its clunky autocomplete features or how it was backed by older, dumber foundation models, and I really didn't like the feeling of not being in control. I was genuinely worried that by using LLMs or agents to write huge chunks of code for me, I'd end up stunting my own hard-won abilities as a software developer. And so, for the most part, I've stuck with using chat tools directly, talking me through all the code changes, teaching me in isolation like a sandbox, and that's worked pretty well for me. But that process can be very slow and arduous, bouncing back and forth between the chat window and the IDE. That said, recently I stumbled on this nugget of wisdom from Gregor Hohpe's new book. He writes, "Identifying technologies that overcome past constraints and seeing how they can change the way an organization works is at the heart of any successful transformation." And I think in some way, this also applies to individuals as well as organizations. So yes, I decided to give Copilot another chance. Worst case scenario, it's the devil you know. Of course, since last time, things have changed quite a bit. For one, now they got that GitHub Copilot Chat agent, and it's pretty much an entirely different product. The user experience and IDE integration has evolved significantly, and what's more, the actual underlying foundation models have gotten a lot smarter. You've got Claude, Codex, and all the others. So anyway, I thought it'd be fun to record this experience and share it with anyone like me sitting on the fence wondering what's changed. Now, for this little demonstration, I decided to build a proof of concept with a couple of requirements. For one, Git is a must. Gotta be able to version and roll back changes fast. Also, I decided to work in a framework that I hadn't used before. I got lots of web development experience, but I've never actually used React. So what the hell, I decided to build a React-flavored Hello World app. But not just any Hello World. I wanted it to look sexy. Cartoon text in front of a spinning star with pastel colors, and I wanted it to bounce when you click on it with a mouse, and for that matter, I wanted it to have an annoying pop-up with a video of Lionel Richie singing Hello, and I even sketched a hand-drawn wireframe. I mean, is that too much to ask for? Well, I don't think so, so let's do it. Now, I've opened up the workspace folder. It's called Application Take 2. This is my second attempt, but don't worry, I'll show you both of them at the end, side by side, for comparison. And also, I've already installed the GitHub Copilot Chat extension separately. It turns out the baseline GitHub Copilot's already built into VS Code now. They're really pushing this stuff hard. With the chat panel open here on the left, I start by selecting the model, Codex GPT-5.3, and I verify that I'm using agent mode. This is the mode that does the most thinking, and it has the ability to make changes on my behalf, with my approval, of course. You can still use the ask mode for a less intrusive chat, or for that matter, the old autocomplete feature still works in line as well. But for this demo, I wanted to go all in and experience something more similar to how I work with ChatGPT. From there, I start chatting, giving it some context about the state of my IDE and my desire to build a React application. But first, I want it to help me initialize Git for my working folder. Now at this point, we're already hitting a slippery slope. Usually, I'd type git init right there in the terminal, but I just wanted to see how far this agent can take things. As you can see, it spits out a string of bash commands to inspect the folder, initialize Git, and verify the status. But it's still up to me to click that allow button, or skip if you want to iterate. But this is the accountability. It's still running on your behalf. Now, because of the model's training and system prompts, it's doing a pretty good job of second-guessing my next steps. It wants to rename the branch to the more contemporary main, add a git ignore file. But first, I check out the source control panel, see that we're all set up and good to go. I go ahead and verify that, yes, this is what I want to do, and it sets things up one step at a time. I allow it to rename the branch, to create the React-specific git ignore file, and I take a peek. Remember, I don't know React. It's got some similarities to an Angular project, and this is an opportunity for me to learn and get familiar with some of the build file types. It's really aggressive with those keep undo buttons all over the place. Not a big deal when I'm using a larger monitor. Okay. Now it's getting eager. It wants to move ahead and build out the React scaffolding. It's almost like they're getting paid by the token. I tell it to create minimal scaffolding using my limited knowledge of how it uses npm and Vite. I'm trying to avoid Thor's hammer of package dependencies. I'm noticing this chatbot is very much an agent with its ability to create plans, to-do lists, and review the context implied from the local workspace. I mean, it's not quite vibing. It's still very human in the loop, and for me, that's the main compensating factor. This time it's asking me to review the changes to the package JSON file in line. This is where things get a bit scary. We've all seen the security issues with compromised packages. As a developer, I'm absolutely accountable for what gets put in there, but this looks pretty vanilla. I'll allow it. Now here you can see all the new or updated files show up in the source control pane, probably the most important view to see the changes. I start by taking a peek at the index file, very similar to Angular with its shell. All the content's going to be loaded in dynamically, so you don't expect to see much here. There's the package file, Vite configuration, app, JSX. Not a lot going on here yet. Main. Alright, next, the agents in Eager Beaver wants me to run install on the Node package manager, then build. And it's like, holy crap man, commit. Nah man, I want to see this thing running locally before lobbing it into Git. I mean some kind of testing, right? So I ask it to actually run the web server. Here it wants me to open the localhost URL in VS Code. I had meant to grab the URL and view it in the browser proper, port 5173, and I want to spot check it. View the source and make sure I can see the React shell HTML. Looks good to me. I ask it to keep the server running so changes get updated automatically in the browser, and from there we commit the batch of changes. That's the plan. Small changes committed one at a time. I do notice this nice feature. If you mouse over the bash command, you get a pop-up explaining what it does. But this starts to become a question of trust. Do I trust the model's explanation of the code? Do I get too lazy to look up what I don't recognize? Allow it. Changes get cleared out. Next, and here's the most important part, we're going to add the bare bones hello world text. I want the view to use semantic HTML. I want the text itself to be set with a variable, and I make an assumption that we'll be using TypeScript with that observable binding. Maybe? Well, not by default. So the agent changes the files from JSX to TSX, and the TypeScript packages are added to the project. Got to install and build those. Get rid of the red squigglies. Hey, I'm learning. After that, the app file is updated with my new variable. Got the curly bracket binding to the HTML in that return block. Refresh the page, see the text, view the source, and notice that it's loaded dynamically in the browser, not bound on the server. And from there, commit. Next, I want to iterate on the design. Make it look splashy. White cartoony text in front of a star shape and pastel colors. Now I gotta pause here and point something out. I told it that I was going to attach my hand-drawn wireframe, but I got so caught up in describing the look and feel I forgot. Earlier, I had mentioned this was take two. In the first attempt, I did attach the file and got pretty much the same results, except it was a bit more irregular looking due to the hand-drawn nature of the wireframe. But in the end, I got nearly the same results. Maybe because my written description was more verbose. My implementation details are biased. I want to leverage a solution that I've done manually in the past using SVG for the scalable lines and shapes, CSS and TypeScript for styles or animations. Here you can see it takes the decision to keep some of the markup, styles, and script all on the same page, and while I'm used to there being a separation of content, form, and function, I think React favors modularity per UI element. Trade-offs, but it does keep some of the more baseline styles decoupled in the new app CSS file. Good enough for a POC. Build. And check it out. For a first pass, it's pretty close to what I want. Good place to commit. After that, I want to make some small incremental changes. I'm going to add a wobbling animation to the letters, but first I wanted to initialize their position to look randomly placed. I realize I'm cheating a bit here, being a bit more specific than I was in my first attempt, shortcutting some of the mistakes I'd made, honoring the letter kerning and positions. This iteration takes a bit longer to process because we got some math for the agent to work on. Scripts and style in the app get updated. I skimmed the code. If the stakes were higher, I'd definitely take more time, make sure the solution doesn't box me in, but it's easily testable, so I go ahead and build it. And check it out, that's pretty close to what I want. That said, I realized that the requirements call for all caps, and so I want to try updating the text myself. I ask it to point me towards where the text is initialized. While it's spinning, I take a peek at the context window, a bit more than I expect for a basic project. I like that it gives me a link to the exact line where the text's set. That kind of integration is super helpful. I go ahead and make the change. Look at me. I'm helping. Build the code, look at the page, commit the code. Now here's where I get a little picky, but it's real important with these things to take small baby steps, small scope, leave the first principles decomposition to me. I ask it to adjust the position of the text and fatten up the star a bit. Here I see it's actually calculating the star coordinates. That'd have been hard for me to do manually. Math. I'd probably have used a drawing app like Adobe Illustrator. Build it. Good. Now for the purpose of this proof of concept, I've got to remember not to let perfect get in the way of good enough. If this was for production, I'd probably provide more assets for design and iterate more, increase the kerning, adjust the color and size. I noticed that the agent was opinionated based on all the other hello worlds it learned from and added drop shadows. I actually didn't ask for that, but that's how it goes. Anything you don't specify, you're leaving up to chance. Let the developer fill the grout between the tiles and all that. Low-risk decisions. Well, from there, commit. Next, now, I want to add a wobble animation to the letters, rotating back and forth about 20 degrees, independently, cartoonishly. CSS is pretty good at these kinds of effects, and the agent picks up on that. Not that much code, a few variables, some styles. Build it. And then I check it out. Good enough for government work. Commit. Now we animate the star. I found asking for that separately helps avoid weird positioning issues. This change is basic. Vanilla CSS. Commit. At this point I get greedy. Here I want to add a mouse down and mouse up event. Make it so when the user clicks down, the star pauses and shrinks, and when the mouse goes up, it goes back to spinning. I used to have a lot of fun chaining animations like this, so I want to see how Codex can handle this. To capture the event, it has to add a wrapper container to envelop all the elements. Separate the object capturing the event from the object affected by the event. Build that. And yeah, this looks good. Now, to be fair, they like to talk about using AI as a skill issue. Here, that definitely applies. During my first attempt, the elements were jumping all over the page. I had to iterate a few more times and get better at writing more specific prompts, but it was manageable because my changes were small. That's key, by the way. Just like with real development teams, you want your story sized at one point for this very reason. Yes, it takes more effort, but you get more reliable results. All right, commit it. Now for the final stretch, I want to get silly with it. On the mouse up event, I want the page to display a modal with an embedded YouTube video with a familiar song. This is a Hello World app, so you know where I'm going with this. 10x border, I give it some embedding font, working, generating. Check out the changes, and it doesn't look bad. I've seen worse, and with the right kind of guidance, a prompter can have it follow their preferred standards and practices. I'll keep the files and build it, and here we go. Click. Yeah, you knew where I was going with that. I wasn't monetizing these videos anyway, right? Now, before we go, I want to also show you the result of my first attempt. They say that the scientific method requires experiments to be repeatable and reproducible. Make sure your results are reliable and not random or biased, right? And also, we know that English language prompts with LLMs aren't deterministic, not the way the code is. If you run the same prompt twice, you're going to get slightly different results, and maybe the differences are low risk enough that it's okay. But this is why we do the agile. We show our work to stakeholders, they give us feedback, and we prioritize the most important tweaks and changes, up until that point where it's good enough. MVP. Now, my conclusion. Did it work? Yes. GitHub Copilot Chat Agent is a very different tool from the last time I tried using it. It's not autocomplete and it's not vibe coding. It still is or can be very much human in the loop, and at least to my level of satisfaction. That said, and I hope you can see it here, there's still very much the risk of complacency. An inexperienced developer, or even an experienced developer like me with blind spots, we can easily become complacent and miss small things. It's unavoidable. Cognitive overload is a physiological constraint. Maybe you hit that apply button a little too quickly, or maybe you got sensitive information in the workspace, API keys, connection strings. It gets logged on OpenAI's servers. It gets logged. Microsoft makes promises backed by terms of services and SLAs, and maybe that gives you a bit of a safety net, but the accountability still falls on you and the organization that owns the code. During this demo, you saw me doing things that should have made you cringe. At least a little. I don't even know React. I don't know what I don't know. For a hello world, that's probably fine, but for production code, you're going to want to put some additional guardrails in place. Nevertheless, AI-assisted coding is here to stay, and we're going to have to get good, sharpen the saw, and apply all those old disciplines. All right. My name's Steve, and I'm on YouTube and LinkedIn, and I'll see you there.